Today's session is Color Standards and Specifications. It is my pleasure to introduce our speakers for today. Carrie Maloney, Field and Channel Marketing Manager, Fiery Wide Format, and John Nate, Worldwide Technical Product Training Manager for Fiery Wide Format. So with that, let us begin. Carrie, it's all yours.
Thank you, Yael. So today's session focuses on color standards and specifications. So whether you're producing production prints or contract proofs, knowledge of the latest color industry standards is a must to satisfy today's customer needs. We will cover why standards exist, what they are used for, and where they play a part in the print process. Plus, we have some advice on document types and settings when working with standards and specifications. But before we make a start, we would like to get a feel for what standards and specifications our audience today currently use. So we'd like to take a quick poll. You should now see on your screen 2 questions. You can choose more than one option per question. And whilst you're completing these for us, I'd like to take the opportunity to remind you all attendees receive, if they attend the live webinar, they will receive a free D50 light indicator. John Nate will explain the use of these within the main part of today's session. So thank you for completing the poll. I will now hand you over to John Nate to take you through the detail on color standards and specifications.
Thank you very much, Carrie, and welcome everyone to our second session. We had a great session 3 weeks ago and expect today's will be just as good. The topics I'm going to cover today: standards, specifications, and methods, what they are, how they differ, why we actually need them in the first place, and why we're actually often wrong when we make our request. Specifications. What are the specifications for documents, for printing, the actual production portion, evaluating the printing process, were we successful or were we not, how to actually do the measurement, and viewing specifications. So let's start with standards, specifications, and methods. What do you want? What are you trying to get? Well, if you don't set standards, you don't know what's right. You send printing out to one company for one type of product, maybe the brochure. You send it to another company for the wide format printing, for the billboard, for the display graphics at the trade show. And without standards or specifications, there's a good chance that the work is not going to match. It may look good, it may look pleasing, but if we want to get things to match, we're going to have to set standards. We're going to have to set specifications. Now, standards are not necessarily what you think they are. We look to the ISO, the International Standards Organization, to tell us what the definition of our various terms are in the graphic arts industry. And standards, not necessarily what you think. This is a little dry, a little extra text, but I'll distill it down to a little more understandable version in just a bit here, so bear with me. But the ISO organization says that standards, it's a document established by consensus and approved by a recognized body. So that body could be ISO, it could be the ID Alliance, it could be FOGRA, etc. That provides for common and repeated use, rules, guidelines, or characteristics for activities or their results aimed at achieving the optimum degree of order in a given context. Now, hopefully, most of you have not hung up yet, so bear with me. Let's move on to specifications. ISO says a specification is a detailed description of the criteria for a piece of work. Specifications for printing can include characterization data, ICC profiles, PDF pre-flight criteria, calibration targets for the print process, etc. Now think about it. This actually sounds a little more like what we actually are trying to achieve, doesn't it? Not a standard, but the specification. The method. ISO says the method is a way, a technique, or a process for doing something. All right, let's distill this down to a little more understandable form. In simpler terms, a standard would be a car. I want a car. The specification would be how fast, miles per gallon, which parts. Is it a diesel engine? Is it an alternative fuel engine, batteries, gasoline? What color is it? 2-door, 4-door, etc. That is the specification. Then the method is, how are we going to put it together? How are we going to assemble it? Moving it now finally into our world, the standard would be a printed piece. It's a brochure. It's a display. It's a cling plastic cooler label that goes into the grocery store. It's the billboard. The specification, what stock, which inks, what are we trying to match? And lastly, the method. How are we going to get to the look that we want? So let's start with document standards. It all starts with the document itself. If the document is not created correctly, well, you've really put limitations on your output provider on being able to get you what you want. So who built this and how was it built? Let's start with document standards. Well, there really aren't any. There really aren't any document standards, but there are recommendations that we can make. Let's begin by looking at images. One of the very common image file types is a GIF file. Now, I don't recommend GIF files for use in the reproduction process. First of all, we can only have 256 colors per file, greatly limiting the quality of gradients or accurate color in general, for that matter. It's basically used on websites, and it's very good for bringing in animations. Anytime you go to a website and you see animation, there's probably a GIF file behind there. So great for those purposes, not so much for the printing process. PNG files, another file type. Well, although this can support more colors, there's no CMYK support. Okay, also it's used on websites. JPEG, very, very commonly used. Now you might be wondering why I'm not recommending the use of JPEG files. Well, JPEG files can support RGB, CMYK, or LAB color. Anyone who's not familiar with LAB, go to the World of Fiery website and take a look at our session from 3 weeks ago where I explained what LAB color is. It can support having a profile embedded in it, so that when I send you a JPEG file and you open it up in your software that is correctly configured for color management, you should be able to see on your calibrated profiled monitor an image that looks fairly close to what I saw on my calibrated and profiled monitor. So that's all good. But compression. JPEG files are, for the most part, always compressed, and it uses what's called lossy compression, and that causes problems in the reproduction process. It creates what are called JPEG artifacts. JPEG artifacts are always seen around areas where there's a sudden change in contrast or density. I'm not sure if you can see it here, but this is a TIFF file zoomed in of a label on a bottle, and here is that same file converted and saved as a JPEG file. Now let me zoom in a bit, and hopefully you can all see what's going on here. You can see there's squares that show up, large blocks, and then all of these odd little artifacts around the letters. These are called JPEG artifacts. And what happens in JPEG compression is the software looks for areas in the image that have pixels that are very similar in color, and it makes them the same color, hence these blocks. Okay, and it tries to simplify the file to save storage space. Now, although this JPEG compression may look okay on a small printed piece or an ad, you bring this image into wide format inkjet printing and blow it up 1,000, 2,000%, and JPEG artifacts become a serious problem. So for that reason, I do not recommend JPEG files. Okay, TIFF files. This is my recommendation. TIFF also supports RGB, CMYK, and LAB. It also supports having an ICC profile embedded in the file, so we can share the files and appropriately view the color. but it uses lossless compression. This is compression that does not create those artifacts. So when we enlarge it, although we are still limited to the resolution of the file itself, we don't have those artifacts causing a degradation of the image. So for images, TIFF files are what I recommend. All right, PDF. Well, the world is going to PDF, and you can just save a PDF file and all is good. Well, not so fast. All PDF files are not created equal. There are many, many different types of PDF files, flavors of PDF files, subtypes of PDF files. One of the first is PDF X1A. So we're used to looking at PDF, but you want to look at the designation past the PDF to see what type of PDF file it is. And X1A is really kind of the least flexible file. It can only contain CMYK data. You cannot embed ICC profiles. And you can't include transparency or layers. However, because of the lack of flexibility, because of those limitations, it is the least likely to cause reproduction problems. So you might find a lot of pre-press shops that are going to print your jobs on press requesting PDF X1A. That's because they're demanding that you convert all RGB images to CMYK, you don't embed ICC profiles, and you don't include transparency or layers, which can cause problems on their RIP that is used to convert the PDF file to their plates or press. So it's the least likely to cause reproduction problems, but there are certainly constraints on the file. Next, PDF X4. We've jumped ahead a few versions of PDF. Now, this is the most flexible. It can contain CMYK, RGB, grayscale images, and spot colors, all within the same PDF file. ICC profiles are allowed, not only on the PDF file itself, but each individual element can have its own ICC profile. So you could have a CMYK image that's in SWAP, and another CMYK image that's in FOGRA 39, along with an RGB image that's in ProPhoto, etc., all in the same PDF file. Transparency and layers are also allowed, but because of all this flexibility, it's the most likely to cause reproduction problems. You need to make sure that your printing provider has the most up-to-date equipment in the way of the RIPs that they're going to use to process your file to print the final image, to make sure that it can understand all of these variables and it won't choke on your PDF file. So PDF X4 is my recommendation when you're making a file that does not, or creating a file that does not just have images, in which case you can just do a TIFF file, but also incorporates vector elements such as logos, things from Illustrator, fonts, text, etc. All right, let's look at our production checklist. We've got our first item taken care of. Our file has been prepared correctly. We've saved images as TIFF files, and we have saved our composite image as a PDF, and likely PDF X4 to be able to use all the different types of color spaces that we want to use in our images. All right, let's move on to printing, not standards, but printing specifications. What do we want the image to look like? In the Americas, we have a number of printing specifications. We have SWAP, which is the specifications for web offset publications. That's your magazines, are often specified as SWAP. SNAP is the specification for newsprint advertising production. This is the color specification for newspaper. Now you can imagine the color specification for newspaper, SNAP, is going to be different than SWAP because we can get much more brilliant colors on SWAP reproduction than we can on SNAP. The grade of the media is lower for newspaper. You can't get that bright canary yellow that you can when you try and print SWAP specification. Well, then we have GRACOL, kind of the newer kid on the block. This is the higher quality reproduction for brochures. Here we can even hit a brighter canary yellow. So SNAP, lowest quality, SWAP, higher quality, GRACOL, even higher quality. A lot of this has to do with the paper, the stock the image is printed on. Newsprint can't hold as much ink as GRACOL, therefore its color space is smaller. Remember 3 weeks ago we discussed color space, and that's the limitation of the gamut. Well, that's where this specification comes into play. It tells us what we are trying to hit for color for gamut. And of course, you can tell that these were all designed by committee because the ever-popular joke that if you mix these around a bit, you get snap, GRACOL, and swap. For those of viewers outside the area of breakfast cereals that we have here in the States, a popular breakfast cereal. First, the flexographic image reproduction specifications and tolerance. Well, that's plastic bags, the bread bags, the bags of lettuce that you see in the store. Any kind of flexible packaging is printed using the first specification. Now, just to complicate things a little more, these are not single specifications. GRACOL has an older specification and a newer specification, 2006 versus 2013. SNAP, there is the one current specification. SWAP has kind of an old specification, US Web-Coded SWAP v2, but that has been replaced by SWAP 3 and SWAP 5. The 3 and the 5 refer to the stock that it's printed on. The bigger the number, well, the lower the grade of paper. So GRACOL is actually a grade 1 paper. SWAP is grade 3 or 5. First can be any one of a number of specifications because, as you can well imagine, you can print on a variety of media. Okay, the harder plastic that goes into the blister packages on the store shelf versus a plastic bag, different capabilities there. So first has its own subset of specifications. Now, outside of the Americas, internationally, we have FOGRA. FOGRA has a number of specifications. FOGRA 39, for example, is a coated stock. FOGRA 48, newsprint. FOGRA 50, gloss laminated. Okay? Then we have 3DAP. 3DAP has come under, or actually changed to conform to some ISO standards. So 3DAP, the committee, as far as I know, has been pretty much disbanded in Australia, but it covered 3 paper types, still is used in some situations, and in the Fiery XF and Fiery XF Pro Server RIPs, we do include the color bar for 3DAP, a little more on color bars in a little bit. Japan has its own print conditions, 4 of them for Japan color. And ISO, kind of the granddaddy, also has ISO-coded, uncoated newspaper, what they feel we should conform to. So we have international standards, we have standards in the Americas, all give you a different look. When you specify FOGRA 39 or GRACOL or ISO uncoated, you're specifying the color of the paper, you're specifying the gamut that the image is printed in, and overall the look. So you have to be a little careful when you select your specification. This is a specification chart, just part of it, for GRACOL, and this is what printers look at. Here is the paper LAB value, 95, a pretty bright stock. A star is 0. If you remember from 3 weeks ago, that means on the A star, the red to greenish side of the equation is neutral, and the B star is -2, so it's a little blue. Okay? Newsprint stock would be a much lower L star value, and the B star value would be positive because it's a much more yellower stock than what we try to print our high quality work on. Here are the LAB values for the primaries. So our CMYK primaries. Now, keep in mind these specifications are for the printing press. The printing press usually has only CMYK inks, where many of our wide format inkjet printers can use specialty inks, additional inks, and that allows us to get an even larger gamut. We have neutral density values, we have density values for the various points along the tone curve, etc. So this is what a printer will look at to determine what they have to do in order to print so that they're in compliance to the specification you selected. Now, it's a little easier in the wide format inkjet arena because all of this information is encapsulated in an ICC profile. So we only have to worry about the ICC profiles. A lot of talk throughout the world right now, really, in G7. And G7 is a method. And all too often people say G7 and they don't use the term correctly, just like they say, I want you to print to the swap standard. No, that would be the swap specification. A lot of people say, I want you to hit G7. Well, G7 is a method. Okay, it's a method. The 7 stands for CMYK and RGB, the primary and secondary colors. The G stands for gray balance, and it was invented in order to help us attain what's called a shared visual appearance. I want what you print on your press to look like what I print on my press to look like what she prints on her grand format inkjet printer. In the early days of printing, all we had to do to conform to a specification was hit solid ink densities. So how dark is cyan? How dark is magenta? And at the 50 or 60% spot, depending upon where in the world we were printing, how much dot gain there was. How much bigger did the dots of ink get when they were soaking into the paper? And that was it. But that meant you could print with cyan, magenta, yellow, black ink. I could print with reflex blue, rhodamine red, yellow, and black. Or my yellow ink could be contaminated with cyan, and I could be printing with kind of greenish ink on my press. But hey, if I hit the densities and I had the right dot gain, I could say I was conforming to swap, for example. However, my press run might not match your press run. So enter G7. But as I said, it's all too often mischaracterized. It is based on LAB measurements, not density measurements. So it's what color is the ink? What color is the paper? In addition to the density. So it kind of covers both worlds. So when people say, well, I want you to print to G7, here's why that's not correct. Let me ask a question. Where are you going? If I asked you that question today, well, you might say, I'm going to New York, or I'm going to Paris, or I'm going to Tokyo. What you would not say is, oh, I'm driving, as an answer to the question, where are you going? Where are you going? Driving. No. That's how you're getting to the destination, New York, Paris, or Tokyo. So in our world, what are you trying to match? What are you trying to match? Well, you're trying to match GRACOL or FOGRA 39 or Japan color. Okay? You would not say, I'm trying to match G7. G7 is how you get there. Okay? It's to try to get the solids to be the correct color and the correct density, the correct paper, good gray balance, so that we can share a look between different devices. And that's what G7 is. There are different compliance levels to G7. There's grayscale, in which case all we really care about is gray balance. We're not conforming to any specification like swap or GRACOL. Don't care if the media is correct or the ink is correct. Don't use ICC profiles. All I care about is grayscale. Targeted, this is the press world. It is gray balanced. It conforms to a specification, swap, GRACOL, etc. It does use the correct media, and it does use the correct ink. So I can't put ISO newsprint media on my press and expect to hit FOGRA 39. Not necessarily going to work. Color space. This is the world of wide format inkjet. We are gray balanced, we conform to a specification, and we use ICC profiles. Instead of the correct ink or media, we might use the right media, but we are definitely using ICC profiles because our inks are not the correct color. We have the limitation of what can come out of an inkjet head, whether it's UV cure, whether it's absorbed into the emulsion on an aqueous inkjet printer, etc. There's also G7 Extreme, which is gray balanced, and we're not trying to hit anything. We're trying to make use of the full gamut of the output device. We want to make it look the best color we can get off of that output device. Now let me talk about G7 Extreme for a moment, give you a little better idea of how that might work. In G7 Extreme, in G7 Non-Extreme, let's start there, if I have a color solid red, on a press that might be printed with 97 magenta, 89 yellow after conversion, etc. But if I print expanded gamut, my 100% red is going to be printed with 100% magenta and 100% yellow. And I'm going to get more saturation, snappier colors. It's not going to conform to the GRACOL standard or the ISO-coded standard. It's going to go beyond that. So I make use of the full color space of my output device. So, what are your specifications? We had a poll at the beginning. Carrie, do we have the results?
This is here. I'm sharing what we got. So looks like as far as what people produce, there's a wide variety here. And then with the specifications, we have a good number on GRACOL, SWAP, and ISO, and then a spattering of others.
No Flexo printers this morning, and everybody in Japan is asleep at the moment.
Sounds like.
Not surprising. All right. Thank you very much. So you can see we all print to different specifications. We all print different types of materials, different standards. And if we continue with our checklist, we now have our file prepared correctly and the specification we want to print to, what we want the output to look like, has been selected. Well, now we move on to evaluation. As we print it, how do we know we hit the specification that we are after? Well, first, we would have to print a color bar on the output. The color bar has to be selected to match the specification you're after. Forgive me, for some reason or other, the Japan color bar did not show up. But you can see ID Alliance, this would be for SWAP, GRACOL, etc. There's an older strip, there's a newer strip. The newer strip has more colors. 3DAP for our friends in Australia, and FOGRA, different color bars. So you would not select the FOGRA color bar to try to hit GRACOL. So you have to make sure you select the correct color bar first. Then, what are you trying to hit? There will be measurements of each of those patches, and we have aims. We have LAB values. If you remember from 3 weeks ago, LAB means what does it look like? What color is it? You can see there's a difference here between, in the GRACOL world, the 2006 versus the 2013 standard. The same brightness of paper, but the newer paper is certainly bluer. It has a more negative B-star value than the older paper that we're printing on. And this was done because the ID Alliance realized that the type of paper that's being supplied from the paper mills does change over time. So because of that, we have to change our specification to conform to the media that we have that we can use, what's at our disposal. The primary colors have changed a little bit, and the secondary colors have changed a little bit. So we have to select the correct aim, and as you can see, you can't just say GRACOL. Well, which GRACOL? Which color bar? Which GRACOL? Those little tiny differences can make a big visual difference, so you have to be careful. On the right, we see the new GRACOL standard, and on the left, the older standard. And you can see the white point of the paper here is bluer on the new standard, and I'm assuming everyone is on a color-managed accurate monitor this morning, and you should be able to see that her face is much bluer than her face because of the color of the stock. That impacts our highlights and quarter tones and everything else. Plus the primaries and secondaries have changed. So you can see it is important to select the correct standard, the correct color bar to measure to make sure we conform to the standard. Then we have tolerances. Well, okay, we're going to measure that color bar. We know what we're supposed to hit. What's my plus or minus? How accurate do I have to be? And each of the governing bodies publishes tolerances. Here is the target tolerance for the ID Alliance. It says we're supposed to use delta E, which particular formula for delta E we're supposed to use, and the delta E for the substrate is less than or equal to 1.5. For the CMY solids, less than 3.5. the black solid less than or equal to 5. So you can be, there's an area that you have to play with. It does not have to be perfect because we all know with the variables in our output devices that's pretty much not possible. So these are just a few of the tolerances that we monitor by measuring our color bar to make sure we conform to the aims of the specification we're going after. Okay. Now here's the tolerance and specification for expanded gamut. Full gamut, bright colors, everybody's just happy. So if you can, push for this because this is a whole lot easier to work with, as you can see. All right, our production checklist, our file is prepared, specification is selected, and now we have selected the correct color bar, the aims, and the tolerances in order to make sure that our output has conformed to the specification, and our customer will, well, number one, sign off on the job, but more importantly, sign the check that they're going to give us. Okay, well, now we have to measure that color bar. So to measure the color bar, we have to look at the measurement standards, and this comes, here we enter the M illuminance. This is somewhat new in our world, and it details the type of light and the type of filter that's installed in our spectrophotometers. Spectrophotometers are the devices that we use to measure the color bar to get the LAB values to compare to the aims. And you can select on some devices different M standards. M0 is UV include, which means if there's any UV light, or there is UV light, I should say, in the light source, and if there's any impact of UV light on the ink or the media, we need to record that as part of the LAB measurement. I'll get into a little bit of where that comes into play in just a bit. M2 is UV exclude, UV cut. There is a UV filter in the spectrophotometer that makes sure that the effect of UV illumination does not impact our output. M1, this is the new boy. M1 is D50. It's a little bit of UV. The standards associations decided that a lot of our work is not necessarily viewed just under light booth conditions where there maybe is no UV illumination, so we should have a little UV in the light sources that we use to measure and view so that we are kind of consistent across the board of whether we're measuring or viewing the output. This is certainly causing some problems when we talk about something called optical brighteners that I'll get to in just a bit. Now, old measurement devices were likely M0, sometimes M2 only. The newer devices can do M1 also, so they can match the new measurement standard. And they also match the new viewing booth lamps. Our viewing booth lamps are now M1, so they have a little UV in them, and when we measure with our output or with our measurement device, we measure that M1 component, that UV component. M1 capable measurement devices right now in the world are the ES2000, the i1 Pro 2, the Konica Minolta FD5BT, the Barbieri Spectro LFP, and the Barbieri Spectro Pad. Those are the four, to my knowledge, that will do M1 measurements. All right, files prepared, specifications selected, color bar, aims, tolerance selected, and now we have the color bar measured and evaluated, and hopefully in our evaluation software, we got a pass on the output. But now we have to view it properly. So what color is your light? Now, to some people that might sound a little strange, especially those outside of the graphic arts industry. What color is the light? Well, the viewing standard, well, we have a lot of problems in viewing. The type of lamps that we use, the color of the light, something called metamerism, and something called optical brighteners. First, let's look at the types of lamps. We can have incandescent lamps. Well, they're very yellow. Fluorescent lamps, well, they can be all over the place. Go to your local hardware store and you can get cool white, warm white, daylight white, etc. And then we have LEDs. LEDs also can come in all sorts of colors. You can get blue LEDs. You can get yellow, red, or what we might consider white. But what exactly is white? Well, the color of light greatly impacts how we see color and how our printed pieces react. Now here we have the same scene lit with different types of fluorescent lighting, and you can see we have a different color look. And that will give you a different kind of emotional feel also under these different light sources. Color of light is listed as color temperature. High noon, around 5, you can see 5,000, 5,500, 6,000. Somewhere in there is what a lot of people call high noon. It is the quality, the color of light outside at noon. It's actually technically a specific location, specific time of day, on a specific day of the year. We won't get into that. But we have daylight fluorescence that are bluer. We have incandescents that are warmer, lower on the scale. So that's one of our first criteria. Are we at our noon daylight color temperature, the color of white? But that's not enough. We have to look at something called the CRI, the color rendering index. The CRI tells us how close the quality of the light, not just the color, but the quality is to sunlight. 100 would be perfect. It would be sunlight. Fluorescent lamps can have a CRI anywhere from 50 to 90. LEDs can have up to 98% or 98 CRI. Well, who cares? What difference does this make? And it has a difference in something called metamerism. Metamerism, big word for the day. Write it down. Impress your friends tonight. Sample colors match under one lighting conditions, but not under others. Huh? Well, I've got one light source here, and I've got two colors. They match, but under this light source, they look different. There are color strips. Carrie mentioned earlier on, everybody that attends and fills out the forms today, we're going to send you a lighting indicator. It's going to be the lighting indicator we use, which is printed, actually they're all printed with two different inks. And the inks react differently under different CRIs. Under noon daylight conditions, you will see no stripes. No stripes. I only have the kind of before here, but this would be one solid color. Under different lighting conditions, suddenly you will start to see stripes. And here notice under tungsten, this lighting indicator, sometimes also called a REM indicator by the gentleman who invented it, but the outside and middle stripe are lighter under tungsten. They're darker under cool white fluorescent. This should be really thought of as an indicator of a fail strip, not necessarily a pass. If you have solid color, it didn't fail. Doesn't mean the lighting is perfect, but if you see stripes, you know it failed. The lighting is not acceptable. You should not look at or evaluate color because different inks will react this way on your media. So you will get a difference, a change from highlights to shadows to quarter tones if the lighting condition is not correct. Optical brighteners is the second problem. UV light causes optical brighteners to fluoresce. If you notice here, two pieces of paper away from the black light, they kind of look the same. They pretty much match. But we hit it with UV light, and all of a sudden the optical brighteners glow. What's happening here is optical brighteners are chemicals added to media, and actually also ink, to make them look brighter. It is less expensive, pardon me, it is less expensive to add optical brighteners to paper to make it look whiter than it is to make whiter paper. So to keep the cost down, they add optical brighteners, the manufacturers. But this can cause problems because it not only looks brighter, but it shifts towards the blue area. What the chemicals do is they take invisible ultraviolet light and do kind of a shift, kind of a modification of it, and reflect it back as visible light, but as you can tell by the ultraviolet portion, it's way on the blue end of the spectrum. So we can have optical brighteners in our proofing media, our production media, our press sheet, and our inks. And that can cause problems because imagine if you have a different amount of UV optical brighteners in your production media than you do in the proof. Depending upon the lighting conditions of where they were viewed, they could match under one lighting condition and not match under another lighting condition. So we have to be careful. We have to make sure that we always look at our products under the same lighting conditions when we are doing our evaluation. Okay? And inks, especially yellow, can have a different amount of UV brighteners than some of the other inks. Well, now there's something that's going to cause problems. Here are yellow ink on top of other inks or not on top of other inks, look brighter and can do a masking job on the media, and let's face it, cause problems. The best would be to get media without optical brighteners, but then your costs are going to go up. The ideal is to use a booth, a light booth that has the correct lamps in it, that have the correct amount of UV light, that match the M1 characteristic of our measurement device so that we know we're measuring the same color as we are viewing in our booth when we are evaluating the final printed piece. If possible, that's the recommendation. So back to our production spec, our checklist. Our file was prepared correctly. We used TIFF and PDF, possibly X1A, more likely X4 for our files. We selected the specification that we want everything to match, whether it be GRACOL, Folger 39, expanded gamut, something that we know we can point to, measure, and say we either hit it or we did not. I'm paying for the job or I'm not. We've selected the correct color bar, the aims and the tolerances, printed the color bar. We've used the correct color bar measurement using our spectra with M0, M1, or M2, likely today, M1, evaluated it, compared the values we got to the aims, and made sure we were within the tolerances for the specification, and then hopefully get a pass for the printed piece. And finally, we all gather around our light booth with the M1 lighting conditions and look at the image and deem it correct. And our production checklist is complete, and please take note, just like 3 weeks ago, color management is not a task or an item, but is an entire process. It's an entire system. So too with production. Whether you're making proofs, whether you're making production output on your inkjet printer, it is a number of items that you have to check off on your checklist to make sure everything is done correctly. With that, thank you for your time, and back to Carrie.
Thank you, John. That was very informative. So what did we learn here today? We learned the difference between standards, specifications, methods, and compliance, and how these differ globally. We also learned how important lighting and viewing conditions are when evaluating your standardized results, and that document standards don't actually exist, but recommendations certainly do. So make use of these, as these will help you produce the best printed products and results for your customers. If you would like to further your knowledge on this subject, we have some resources for you. We have five websites to recommend. We first have the ID Alliance. They have their Just Enough video bank that covers topics such as G7 and GRACOL. You could also visit fogra.org, where you can read up on the latest news and advice on standards and specifications. We also can recommend the Ghent Work Group website, which is very useful for best practices for publishing and packaging workflows. Also on xrite.com, you can get more information on the M-illuminants that John mentioned for measurement devices. Plus, on Wikipedia, you can find a detailed overview on PDFX. Okay, so on today, our second session in the wide format color series, we covered color standards and specifications. We have our final session in this series on July the 8th, where we will cover color management inside Fiery XF and inside the Fiery Pro server. This is where you can put your knowledge into practice and understand RIP level color controls. And once again, as a reminder, we have our production series for wide format printing starting this September. Details can be found on the World of Fiery Webinars homepage, and registration is now open for these additional sessions too. So we will now take some questions and give you some answers.
Thank you, Carrie. Thank you, John. So as Carrie and John start looking at the questions folks have submitted so far, I do recommend that if you do have any questions, please submit these right now. Either the chat window or the Q&A window, both will work for us, and we'll do our best to get to your questions. Again, as they're preparing, I just want to remind the audience, we did record today's session, so if you want to go back and listen again or share this with a colleague who missed it, we'll provide a link. We'll also provide a copy of the presentation. A couple of you asked about that, so that will be made available, and we'll of course provide the links that Carrie mentioned to all those wonderful resources so you can have ready access to that. All that's going to be sent out to you via email within a few days. We'll try as quickly as possible, but expect it early next week. If we can, we'll do it sooner. Carrie, John, are you ready with some questions?
Yes, absolutely.
Yes.
Okay, John, so are we working towards a worldwide standard?
Worldwide standard, worldwide specifications, probably. Well, in a way, yes, we're all trying to conform to ISO when I attend the meetings of the ID Alliance. Part of the problem throughout the world is a lot of the governing bodies are saying, I am perfectly happy if the world comes to one common specification as long as it's the one I use. And that does cause some problems. But what we are finding is a lot of similarity, and we can move. I remember a number of years ago I was involved in working with Sotheby's in London, and Sotheby's in London wanted to print to match printing in the U.S. Well, there was no way we were ever going to get someone in the U.S. to accept FOGRA as something they were supposed to print to, nor would we convince someone in England that they should print to one of the U.S. standards. But we did find that GRACOL was awfully close already to one of the FOGRA standards, and with just a little nudging of the data, still within compliance, but this is what we'd like you to hit, we were able to get items to match. So we are trying to move to that. You also have a matter of taste in different parts of the world, what people consider looks like good printing. So we are certainly trying. I know the new method for determining delta E, we have determined at the ID Alliance, I'll put my ID Alliance hat on for a moment, that we are not going to adopt the new delta E standards until ISO does. That we are trying to say this should be a worldwide standard. It shouldn't matter where you're printing. If you specify a particular specification, you should have confidence that you know what you're going to get as the result. So we are trying our best to move in that direction.
Thank you, John. Second question is, how often should I calibrate my spectro?
Spectrophotometers often do a calibration routine when you turn them on or use them for the first time. They often will either do an internal calibration, or in the case of the ES2000 device that we use at EFI, they'll tell you to put it on the plaque. By the way, the plaques are serial numbered to the device. Make sure you don't mix them up because they were calibrated to that plaque at the factory. I know of someone that purchased 3 ES1000s online, and they came and none of the 3 serial numbers for the devices matched any of the 3 serial numbers for the plaques, and they were forced to send them back to X-Rite for recertification. Okay, and that's a little different. So the devices will calibrate regularly, but X-Rite and other manufacturers do recommend sending them in to be recertified once a year. I'll be honest, the majority of people never recertify their output device. Now, be careful, make sure they aren't dropped, make sure they are treated as the precise devices they are, but if you live and die by the color, you may want to consider every once in a while sending them back in for recertification. As I said, X-Rite recommends annually.
Okay, thank you, John. So question number 3. Our dealer told us to change the lamps in our light booths before they burn out. Is this correct?
Absolutely. A lot of people think that fluorescent lamps, as long as you turn them on, they are still good, and that is not the case. The quality of the light, again, we're getting back into that CRI and color temperature and all that, they will start to change over time. And just like you'll notice if you turn on a fluorescent lamp, towards the end of its life it starts to flicker. Well, it still works, but boy, that quality of light, that color of light is far from what you want. One of the manufacturers, I think it's, I want to say it's GTI, Use Normalict might also have this capability. You can get light booths from them that have a built-in timer that will monitor how long the lamp is turned on. And kind of an average that I've seen is 2,500 hours, and it's time to relamp. Now, last time I did the math on 8 hours a day, that means annually change the lamps. If you use the lamps on 2 shifts, then every 6 months you're changing the lamps. I also know companies that will change lamps at different times. So if they have 4 lamps in their light booth, they'll change 1 in January, 1 in April, etc. So they kind of rotate the lamps. That can be a little dangerous if that first lamp has been on for 16 hours a day because it should have been changed every 6 months instead of once a year. But that's kind of the rule of thumb is, that I've seen is about 2,500 hours.
Okay, thank you. So we have another question on spectrophotometers. I understand that the ES2000 can be switched between UV cut and non-UV. Is there a physical switch or how is this done?
There is not. It's software controlled. There is actually a pair of light sources inside the ES2000. That's how most of these devices work now, where one emits UV light and one does not. So if you are UV 0, no UV cutting, then it is the visible lamp only. And if you say you want M1 or M2, then that would also use the UV illumination. It kind of throws some people for a loop because the way the ES2000 works is you measure once with the visible light and once with the invisible UV light. And it'll say it'll tell you in the interface, especially in the FireX rip, to measure the strip again. And you go, well, what did I do wrong? I thought I measured it correctly. And you measure it again. Okay, well, then it took it. Then you measure the next strip. Oh, it says measure it again. Well, it's actually measuring once with UV, once with non-UV light. And you need 2 passes in order to get that to work. And then the software will combine it to give you either the M1 or the M2 LAB values.
Okay, thank you.
Mm-hmm.
Which specification would you recommend for a VTech QS2000, GRACOL or swap?
Yes. A lot of that depends upon the media you're printing on. You might be printing on a media that does not have the white point or just cannot hit the standard. We actually had, I remember talking to Mike Morrison. He's kind of the head of color out in our Meredith plant, and someone was looking at purchasing a VTech and said, I want you to print on my media. And we said, okay. And we said, what do you want us to hit? What is your specification? And of course the person said G7. And we said, G7 is not a specification, it's a method, explain that. And then he finally said, okay, yes, I meant GRACOL. And that, in our world, G7 has kind of become the Kleenex of GRACOL. When they say G7, they're often meaning GRACOL. Well, the white point of the media was 90. If you remember, the white point for GRACOL is 95. And it could not hold yellow ink for whatever reason. We think it was a lot of UV brighteners that was kind of deadening the yellow. So we could not hit GRACOL on that media. We could barely hit swap because of the UV brighteners that were in the media, but we could get there. So much of it depends upon what you are trying to hit. You know, obviously in my world I say, you know, try to hit the best you can. Expanded gamut would make use of all the color available. The downside of expanded gamut is it's hard to repeat it month to month, year to year. GRACOL, SWAP, FOGRA 39, ISO-coded are all subsets of usually the full color space we can hit. So we can probably come back to them if we have to reprint a job later. That becomes a little dicier if you're doing full gamut or expanded gamut printing.
Okay.
So ultimately it's test and see what the device can give you.
Okay, I think we have time for a few more questions.
Okay.
So if a UV lamp shows optical brighteners in the media, is it better to use the UV filter on the i1 Pro?
I have never been in a situation where I have, excuse me, where I have measured with M2 or M0, UV versus non-UV, and not been able to edit the final profiles to get the color if I wanted, get the color I needed if I wanted to. I could always push the yellow curve, maybe edit the white point to get a little yellow ink in there, or pull some back, get some cyan in there. So you can always, with, at worst, profile editing, usually get to the look you want. It's certainly a lot more work. The ideal would be to use M1. That's kind of what our specifications are all built on these days. If you use the current GRACOL or swap standards, and I know FOGRA, I believe, has also moved or is moving to that, using the M1 measurement characteristics, well, then measure M1, view M1, and then you don't have to worry about it. Otherwise, you can certainly use M0 or M2, but it may mean you're going to have to do some color editing.
Okay, and what is preferred for offset printing, D50 or D65?
That again would be the illuminant. D50 was always the original offset, or excuse me, a viewing booth color, and we tried to do that on our monitors, and D50 monitors tend to look a little too yellow. It's the way the eye works. The retina of the eye has different sensitivity to emissive light from a monitor versus reflective light from printed pieces. So we switched, oh gosh, a number of years ago to the D65 standard for monitors, making them a little bluer to conform to the same look, to try to get the same visual match when we were looking at then our reflective art, our printed pieces. So the viewing booths, well, technically D50, but again, we're looking for that high CRI. My recommendation is get your lamps from a manufacturer of the viewing booth. Contact Use Normalit, contact GTI, contact, I think X-Rite sells them, but contact the manufacturer and get those lamps. Don't try to source the lamp, you know, at the local hardware store. You're just going to, you know, cause more problems than money you're going to save. So get the correct lamps to hit the M1 measurement. That's what we're all trying to conform to now. So I would say rather than D65 or D50, we're looking at M1.
Okay, thank you. So we have a question that I can answer here. We have an attendee that doesn't recall handing over an address for his free D50 light indicator. So if we don't have your address, we can ask you for it. We should have most people's addresses, but we certainly have your email addresses. And if we don't find an address associated with you, we will send you an email to get your full address. So next question for John. Is there a new standard viewing booth light replacing the standard 5000K fluorescent we currently use?
Well, it depends upon how old those lamps are. It gets back to the new lighting standard that was introduced in 2009, if I remember right. So as long as you don't have old lamps and you've gotten the lamps from a graphic arts light booth manufacturing company, you should be using the new light standard.
Okay, I think we have time for one, maybe two more questions, so let's give it a go. Okay, why hasn't SWAP adopted a newer specification since paper 3 grades have become bluer and slightly brighter?
The standards organizations changing is much like putting the brakes on the Titanic. They are very slow to move. The standards, I sit on the print properties and colorimetrics board for the ID Alliance, and we meet twice a year. And a number of years ago, when I started on the board, I proposed something, and they said, all right, document that and come up with a subcommittee for the next meeting. 6 months later, did that. Subcommittee was approved. Then the subcommittee talked, came up with some testing ideas, how we would test. 6 months later, met with the ID Alliance. They passed on that, or they signed off on that. Then we did the testing, et cetera, et cetera. So you can see it is quite a lengthy process. Case in point, delta E calculations. There are a number of different calculations for how you determine what the delta E value is. And they keep coming up with math algorithms that try to mimic in the math better how the eye sees color. So the delta E of 5 between two yellows looks like the same amount of difference as delta E5 in grays. And if you use the original delta E value, that is not the case. You might need a delta E13 to be able to see a color in yellow difference, but a very small delta E difference in gray to see the difference. Now the newest is delta E 2000. It was invented in 2000. It is really now finally just being signed off by the ISO committee and adopted by everyone. Delta E 2000. Okay, that's 15 years it took to finish the testing and evaluation and adoption. So all I can say is, because especially we're talking about international boards now trying to work together, it's just very slow. I wish it weren't, but it is.
Okay, so we have time for one more question. Does TIFF or PDF format affect the speed of ripping?
Well, possibly. It depends. There's more to it than that. TIFF files tend to be fairly simple files, and when they go through a rip, what the rip is really doing is doing a color conversion, much like you would do in Photoshop. So let's say you have an RGB ProPhoto TIFF that you are converting to ISO coded. You can do that in Photoshop, and depending upon the size of the file and the power of your computer, that's going to be a fairly quick conversion. Then it is simply scaled to the proper output resolution for the, let's say, the heads of the inkjet printer, so that we get the correct DPI. Okay? Well, that's very, very fast, and that's what a RIP is doing with TIFF files. Now, with PDF files, all of a sudden you get into multiple conversions inside, layers, and vector elements. Vector elements are mathematical elements that are generated from packages such as InDesign. They can be fairly complex. And I had a customer or a dealer who contacted me and said that their customer had a file that would not rip in the FireEXF rip. And I said, could you send me the file, please? What is it? He said, it's a PDF file. I said, how big is it? He said, it's little. It's like an 8.5 by 11, and it's 10, 15 megs. It's hardly any size at all. And it's just not ripping. So he sent it to me. I brought it in my copy of the rip. I've got a fairly beefy computer here in my lab, and it looked like nothing was happening. But when I looked at the performance on the processors on my computer, they were pegged at 100%. They were working their little hearts out. Well, I took that PDF file and I pre-flighted it, something that I do recommend you do. And it had 44,000 vector elements with transparency. That file took 26.5 hours to rip. I took that same file, I flattened it. It took 12 minutes to rip. So there is so much that you can do inside a PDF file that can really slow down a rip. There is far less you can do in a TIFF file to slow down the rip. So TIFF files normally are faster because of all the things you can do, and therefore a lot of people do in PDF files.
Okay, thank you, John.
All right.
You're welcome.
So I think we still have a number of questions we didn't get to. That tends to be the case. And as we mentioned earlier, we will get back to you. If we didn't get to your question during the Q&A phase, we'll get back to you individually. We tend to do that anyway, even if we did cover it, just to make sure that you're around and got the answer you wanted. So I want to thank our audience for joining today. I want to, of course, thank John and Carrie for the wonderful presentation. As a reminder, we have another session in 3 weeks, so hopefully we'll see you there. And until then, thanks everyone. We'll be in touch with our follow-up email early next week. Take care.
Thanks, everybody.